This assessment asks us to start with the alkene and synthesize the acid chloride. It recommends a synthesis that involves 3 steps. Now, even though we're approaching this, at least initially, as how do we go from this alkene to this carboxylic acid, as we do with all synthesis, we want to work backwards. And so what we're going to ask ourselves first to start this process is, what are the ways we know to make carboxylic acid chlorides? Acid chlorides. How do we make acid chlorides? I kind of gave away what the answer is going to be. We're going to start with a carboxylic acid. And so we can draw this carboxylic acid as the molecule that we would start with for making this acid chloride shown here. Now, to convert a carboxylic acid to an acid chloride, we need the reagent thionyl chloride. This changes our synthesis question now to how do we go from this alkene to the carboxylic acid? We're still going to work backwards because even though there are conditions that could probably do this, we're going to use milder conditions to come back from an alcohol. So if we want to make a carboxylic acid, recall that we can use chromic acid and a primary alcohol to convert or to synthesize carboxylic acids. So chromic acid in water will convert the primary alcohol to the carboxylic acid. Now the question becomes, how do we go from this alkene to this alcohol? And what you notice is that we've put the hydroxyl group, if we look at the alkene, the hydroxyl group has been added to the least substituted carbon, or this is the so-called anti-Markovnikov alcohol. To make the less substituted alcohol, we're going to use alkene chemistry. Step 1 is to do a hydroboration. And then in step 2, we treat the borane that is produced with hydrogen peroxide in basic solution, sodium hydroxide, to convert that alkyl borane into the primary alcohol. So by going from the alkene to the primary alcohol, we can then make a carboxylic acid, which we convert to an acid chloride. I'm sure there are other ways that we can do this, but this is one example of a 3-step synthesis of the acid chloride.